And hello, everyone. How are you doing, Mama?
I'm doing all right.
Good.
It's hot out, so
Yeah. Yeah. Summer's not fun because of the heat and stuff. Not pleasant.
Yeah, I like neither heat nor humidity.
Yeah. All right. Ready to get some Sudoku puzzles solved?
Yep, let's get going.
All right. So today's first puzzle is going to be the rabbit of Kerbanog by Ollie Wright. Normal
Did you
Sudoku
hit
rules.
record?
Oh, I did not hit record. Start that over again. First puzzle today is going to be the Rabbit of Kervanog by Ollie Wright. Normal Sudoku rules apply. Place the digits 1 through 9 once in every row, column, and 3x3 box. Adjacent digits along a green line must have a difference of at least 5. Digits separated by a white dot have a difference of 1. And while digits separated by a black dot are in a 1 to 2 ratio, not all dots are given. And I have an interesting habit of reading words that aren't there, but that is what it is. All right, it's just standard rules, other than we have the German whisper line and a couple of crappy dots. Well, I guess the easiest thing to start out would be to give some binary coloring here. Uh-oh.
Uh-oh.
I was getting some feedback. Is it playing through the speakers?
Is what playing through the speakers?
On your computer. Like my
No.
audio?
No. Although I did pull up how to pronounce for Kerbanog, and yeah, that's it, Kerbanog,
Oh, maybe that was it.
because it's Welsh.
Mm-hmm.
And it's like, yeah, that's.
All right. I think that is everything painted. Um, uh, in the way that it needs to be painted.
Yeah.
And I guess looking across here, we've got 4 purples already, which means that 4 is orange, which switches all of our oranges to blue and our purples to red, and that makes things a lot easier. And I can't put a 5 on a black crappy dot because twice 5 is 10 and half 5 is a fraction. So that puts the 5 over here with a 4 or a 6. And this is some high digit, which I think has to be 6 or 8, which would make this 2 or 4. Not 2, 3 or 4, which is a low digit.
Um. Okay. Uh, I must be missing something.
Uh-huh. Is Discord not,
No. On the 4 in the middle.
yeah.
4 of those. 4 of those. If it's. Yeah, I guess I'm not seeing why it can't be high instead of low. Like that can't be a 6.
The 4 in the middle,
Uh huh.
it was a given 4.
Oh, it was a given. Okay, never mind.
Oh, let's see. Where do we go from here? 1, 2, 3, 4 reds means this can't be a 6 because that would be 5 high digits. So this ends up being blue. And these end up having to be red because there's already a 5 in the row. 1 or 2 there.
I guess I'd realized it was printed in black that it was actually. Apparently, I'm not paying attention tonight.
It happens. It's really easy to overlook the color of the digits. Well, I've already got 5 in this column, but I only have 2 reds and 3 blues, so that's not helpful yet.
Okay, at the top of box 5, that would have to be a 9 because it
Not
goes
necessarily.
to. I guess it could be an 8.
It
Well,
could
it
be a
goes to
7, 1,
all
2 pairs.
3. No, it can't. It has to go to all 3.
Oh, right.
Box 2.
So this has to be 1 or 2 because it'll be next to a 7.
Right.
Yeah, I missed this one for some reason. Well, this one can't be a 6. But this one could. That one could, this one can't. This one can't. This one can't. And this one can't. It's got 2 in the same column.
Right.
Both. Well, this can't be a 6 because it sees 1.
In boxes 7 and 9, the blue goes to 3 different cells. So that has to be an 8-9 pair. I'm sorry. Yeah, a 1-2 pair.
Yeah. Oh, one of these has to be a 6. Because of the 7, 8, or 7, 8, 9 over here. So that means one of these is going to be a 1. So we end up with a 2 here.
Mm-hmm.
And the other is going to be a 3, which means this is 6,
So it
8,
has
9.
to be an 8 or 9. Yeah. Which means one of the blue ones below those red has to be the 1 because one of them's next to a 7 and it can't be a 2. Not that that's helpful, but.
Yeah. This can't be a 6, it's 7, 8, 9. This can't be a 6, 7, 8, 9. This can't be a 6, so it's 7, 8, 9, because it's got neighbors that have to be 1, 2, or 3. This one could be 1, 2, 3, or 4. Can't be a 4, so we've got 1, 2, 3. Triple. So 4 ends up down here, which means these are 1, 2, 3. Or that one's not a 2. Because where can I put 4 in here? Well, it can't be red ever. It can't be either of those because the 4 there. And either of those can't be a 4 because you'd end up with 2 9s in the box. So 4 has to be one of these. This is a 1, 2, 3 triple.
Box
This
8,
is 5 or
the
6.
red goes to 3 blues, so it's an 8 or 9. I guess that means the last 3 in column 5 are 6, 7, 5, 6, 7. Yeah, that was it. I knew I was missing something.
These have to be 7, 8, 9. Because their neighbors are in the same box.
So those are 4, 5, 6.
So 4.
Row 2 needs a 4.
So that's not there. Can't go here, and it can't go here. You can't put it in either of those. Oh, I must have put a 3 and thought it was yeah, I must have messed that up.
I don't know. I missed it, so.
Yeah, and I removed it too quickly. 3 has to be one of these two, so it's not there. 6, 7, 8, 9. And this is 5 or 6. Because that's all that's left in that box.
Yeah, column 7 needs a 5.
The blue pair.
Row 5 needs a 5.
Go there. So this is a 2. Places a 1, a 4, and a pair of 9s. Ends up being 3, 2. Means that's a 1 because this has to be the 7. Because this one pairs with that one because this had to be a 6. This is an 8. 9. 8, 7, 8, 7, 9. Not a 7, not a 1, not a 3. 1, not 1s. 2, 3 pair makes that a 1. Not a 7, 8, 7. Not a 5. 9. Neither of those are 8s. This can't be a 6 anymore. So that's not a 7. That's a 9. Not a 3, not a 1, 2. 6 and 9 are out. 8 is out from those. This is an 8, which is red. This is apparently a 1. Apparently that's a 6. That's a 9. That makes 5, 6, 5, red, gray, 6, 5, gray, red, not a 5, 7, which is red, 8, 7, and 8 can't be next to a 4. This can still be a 4 because we got a pair of 9s as neighbors. 6s are red. This is what, 4 and 8? 3 and 6. 3, 6 this way, 8 there. Blues and the reds.
Ah. Column 6 needs 4, 6, or no, 4, 8, and 5.
No, it's not 8. This is also 4. Well,
That side also needs a 6.
6. Oh. can't put 6 here or here, and then this one can't go there or there. So that's a 6. 4, 5, 8. Well, it's not 5 or 8. 2, 3. Okay, well now where can 8 go in this column? It's not in the middle box. It's neither of those, and 8 isn't 6. That's low. That one can't be an 8 because of that, so that's 8, that's 4. Red, blue, 5, 8. So these two are low digits. 1, 3 pair. Five is one of these two. This is what,
Well,
3 and 7?
2, 4, 5, so. Because it's.
2, 4, 1, 2, not 3, 1. I need
3 and 5.
3. 5 here.
Yeah.
2, 1, 3. 4s and 3s are low. 5s are array. I don't see 4, which goes here, which is blue, which means this is a red 6. And then you can't put a 7 next to a 3, so these ends up with 9s and 7s. Alright,
well,
that was a good puzzle.
I thought.
Yeah. Alright. Oh, I didn't need to close out of that. In case we wanted to come back to it later. Alright, so the next one is Killer Pool by Brunel. Normal Sudoku rules apply. Within a cage, digits do not repeat and sum to the total given. A gray square contains an even number. A gray circle contains an odd number. The 9 pool balls in the bottom half of the grid contain all 9 digits. Alright. That would be these.
Yeah.
16, 7, 9. This is a 1, 3.
There's a 3 cage in box 3.
1, 2, and a square has to be even, so that's going to be a 1, 2. I like how this had to be an odd circle. That's probably for the cue ball and our corner pockets. Or,
there's a 2 cage in box 1.
Why not just make that a given? I mean, it's probably for aesthetic reasons, but a 1 cage.
1 cage, yeah.
5, 6, 8, 9. 1, 2, 3, 4. Where that's not a 1, that's not a 4.
15 cage in column 9.
6, 7, 8, 9. This one has to be even, so 7, 9 is out, so 6, 8 is out on the other side. 41 means we end up with, what, 4 left over, which is going to be a 3 and a 1, which automatically places a 7. 7 is 1 through 6, but not 1 or 6, and our even digit is not 3 or 5, so 2 and 4 is out of the top. 39 plus 1 is 40, so that leaves 5. 5 and 9 out of our 14. And 4 and 5 is out. 2 and 7 and 3 and 6 makes this a 1, 8 pair, so we get a 6, 9 for 15.
Yeah. Well, you might as well get the evens in the gray squares.
Right, this ends up being a 4. And 2, 4, 6, 8. Not 2 on the top, not 4 on the bottom. 2, 6, and 8 was already taken care of. Of course, that being a 4. And what, 5 and 7 left over?
Yeah, the 1, 8 in box 9 takes away the 1 from the 5 cage.
So we get a 2, 3 pair here. Doesn't seem to have any other effects, but we've got a 6 here. Never 3s, and the top's not 1, so the bottom's not 5. This ends up being 11.
Yeah.
And the top's not 3, so the bottom's not 8. Because there's a 2, you can't have another 2 9 in the cage.
Top can't be 7, so the bottom can't be 4.
Right. That's 7 9
yeah.
there. Yeah, might as well fill in this 11, which the 9 here removes the same 2 9 pair that happened over there. 3 and 8 is removed. And then I guess maybe we look at this 10. And never 5. The top's not 1, so the bottom's not 9. And this 2 3 in the pool balls removes the 2 3 from the bottom half, removing 7 8 from the top half. Not sure what else to do with that, although I'm going to go ahead and fill these in. 2 and 3 is out. 1 is out of all of those, and that one. And 7's out of there. So 1 has to be one of these two.
Mm-hmm.
Which I guess we get from regular Sudoku anyway. Right, well, maybe the 12? Well, you can't have a 2 in it, so you can't have a 9, because that would make the smallest possible a 1 3, which would require an 8. You can't have 7 in it at all. Top and bottom can't be a 1, and you can't have a 6 there. So, no 2s.
Can't have 7.
Alright. There's only 3 remaining possibilities, but I'm not sure how to think about that. For the moment, where are all my 1s? Well, in this box, it's top or bottom of column 3. 1 and 4 here. One of those two. Top or bottom there. Guess what's left over in this box? That'd be 4 through 9. Doesn't seem that useful. Got 4 through 9 going across the top as well. I'm going to go ahead and take this out because they're not within clues. And it's too many digits.
Yeah.
Going along the bottom, 1, 7, 5, and 4 are all out.
Oh, okay. Since there's a 5 in column 8,
Mm-hmm.
and there's a 5 7 pair in column 9, and the 5 would have to be if no, never mind. That wasn't that was wrong thinking on my part.
Mm-hmm. The only clues we really have left is this group, isn't it?
Yeah.
Okay, I guess where in this group is this digit? It can't be any of those, and it can't be that. Well, those are now the same. 6, 8, 9. So, what about these two digits? Aren't those in blue? Well, they can't be any of these, and they can't be red, so these two are blue.
And none of them contain 4 or 5. Or neither of them contain 4 or 5. It's 2, 3, 6, 8, 9. So the top would be, 6, 8, 9, not a 7
And
either.
7's out either, also. So with that, I guess I should make these like blue green.
I'll make one of them blue and the other one green, and it's blue-green on the bottom.
Yeah. Oops. I was about to ask where the other 2, 3 is in this row, because only one of these can be 2 or 3. But if this is a 3, that can still be the 2.
Yeah.
the 12 has three options. 1, 3, 8, 1, 5, 6, and 3, 4, 5, none of which I think are going to cause problems. Because you can put a 5 and a 6 here, and you can also put a 3 and an 8 there. And then all of them do 3, 4, 5.
In box 5, the 11 cage.
Yeah.
5 doesn't have anything to pair with unless the 6 was accidentally deleted.
I'm going to say it was accidentally deleted.
Okay. Because I couldn't see where a 6 was removed, so.
Neither could I.
Where does green go in column 6?
It's not here, and
That's
it's not
column
blue.
5. Oh, but where does
It can't go here. It can't go in either of these. But it's not forced to be in box 5.
Yeah, but it could be at the bottom, yeah.
We know that all of this is 45. And we know that these 3 are the external 3. Or rather, the bottom 3 are the external 3. But I don't think there's any mathematical thing we can do with that. What's the rest of this column? You don't have 1, 2, or 3 in here. You don't have 7 in either of those. 7, 9, and 2. So where is 3 in this column? It's not in the top box. And it's not down here. So it's either in the 12, or it's where this 1 is. So if this is a 1, Well, then it would be with the 12. So this isn't a 1 or a 3. Because you can have 1, 3, 8. If this was 3, 4, 5, this cannot be a 3, 4. It would have to be 2 and 5. But you can have 1, 5, 6, which places a 5 here, which would make that 3 and 4, but that would be 1 and 6. If it was 3, 4, 5, you have your 5 out here, and your 3, 4 here, and that would be 2 and 5. How is this such a hard puzzle? This 11 and that 11 have to be different 11s. And this digit from the 10 sees all of the 11s. Can't have a 9, so it's 3, 8, 4, 7, or 5, 6. This is 3, 8, 4, 7, or 5, 6. One 9 doesn't interfere with either 11. 2, 8 does, only as far as it removes the possibility for this to be 3, 8. But because that would be a 2, this one isn't affected.
Let's see.
Although,
If the 10 is 4, 6.
yeah.
Then that has to be 3, 8.
And 4, 6 can happen in either direction. But this
Right.
would not be able to be 3, 8, so it has the other of 4 and 6. Which doesn't seem that useful.
All right, let's look at something. If green is 2, it makes the 6 cage above it 5 and 1. which makes it 7 and 5. And I don't think that does a darn thing for us.
No. Nines, eights, sixes. The only thing that's really restricted here are ones and threes. Well, sevens are interesting in the top row. Yeah, where can a 7 go in the top row? It's obviously not 1, 2, or 3, and 7's odd, so it can't be on an even square, and this 7 means it can't go there. But how does that combine with this 16 as a 7, 9 here? Well, 7's here, which would make this 9 and that 7, or 7's here, making that a 9 and that 7. So we end up with sort of this pattern. But what does that do here to this 5, 7? Well, this has to be a 5, because if it was a 7, then I'd have to put the 7 here, which makes that a 9, and that a 7, and now I have two 7s. So this cannot be a 7. This has to be a 5 and a 7 there. Does that make sense?
Yes.
Okay.
And the 7 has to go in in row 2, one of the first two in row 2.
Right. Okay, what about here? 3 has a similar thing going on. Yeah, I think it's just 3. Although I guess 9... Well, no, because there isn't like a pair that... So the 3s end up being similar, but there's nothing like fancy going on in this column with 3s, or like in this box, or anything like that. I just know that 3s have to be one of those two in this box, but that's just regular Sudoku. 3's not even. Wasn't the pair in the 8, and you've got a 2-3 pair there, so didn't need advanced logic for that.
Well, one of the two in the center column of box 9 has to be the 7. Not very helpful.
Yeah. 1, 8. 4 and 5. Can't put a 3 in any of these. Oh, and this can't be a 7, because the 7's up here, forcing 7's down there. And red has to be across this top row, but that can be 6 or 9, that can be 6 or 9, and that can be 8, so that doesn't change red in any way.
Right. I hate the fact that I'm not thinking of stuff. This is it just I don't know. Put digits in here, take out 5 and 7 from all of those, but it didn't feel like a useful thing to do, although we got 4, 6, 7, 8, 9 over here. 4, 5, 6, 7, 8, 9. That's just all the digits. Yeah, but it can't
Except
be 7 or 9.
9. And this one can't be 9. And this one can't be 9. So I end up with 5s here. Isn't that helpful? But now, where are 9s in this column? They're not in the 12. They're not 2 or 7. And now that can't be a 9 because of that, and this can't be a 9 because of that. So 9 has to be one of these two. Mark that in orange real quick. The only spot where I know 9s have to be are these, but they don't, connect in any way. So maybe that's not a direction to go in. 1 and 7's out. 3's out from there. 2 and 3's out from these. I guess I want to know where is 2 in the center 3 rows. Because you can't put 2 here or here. It can't go there, and it can't go there. And both of those can be 2. That can't be 2 because it's paired with an even digit. Is there any reason 2 is removed from anything else? I don't think so.
Oh. Yeah, don't think so.
Put in a lot of stuff that has a lot of digits. It's like, what's going on over here? 7, 6, and 9. Can't put 1 or 5 in there. But that's not affected. But this is 2, 3, 4. 6, 8, 7, 9. That's just all the digits. But now this can't be 2, 4, because there's not enough digits to go in here somehow. Yeah, because these are only 2, 3, 4, and 8. So if this was a 2, 4 pair, this would be a 3, 8 pair, but in 3 digits.
Right.
So this is 1 and 5. And now this can't be 1, so it's 3, 4, and 5, or you can't put the 5 here. But now this can't be 3, 4, because it would break that. So this is 2 and 5. So that ends up being a 5. 4's out from everywhere. 5's out. 3 and 5 are out. This has to be a 1, because we've got a 6, 8, 9 triple now. 5's out of this box entirely. Those aren't 2's. Don't have 5's there. That's not a 2, not 1 or 5. 5, 6 pairs out of the 11. 5 and 6 out from the top of that. This can't be a 3, because we already showed how. Six, 7, 8, 9. 7, 6, and 9. Two, 5, and 6 across the row. 7 that row.
Oh, box 1, 5.
5 and 6. Where is 3 in this column? It's not in these boxes. It's not there, and 3's not even, so that's a 3.
Row 6, 5. Row 6, yeah.
5
5.
isn't in these. It can't be blue, and it can't be in a 10. It's 5 out of box 1. Cell 3 at least. Oh, this cannot be 5 or 6. So 3 or 7 is guaranteed. So that's out, and that's out. So 2 has to be one of these two. Where's 6? Not there, not there. That can't be a 6, because that can't be a 5. So this is our 6. This ends up being a 7. Makes that a 7. And 8, 9 makes this a 6.
Well,
Which
and
means
6 takes 8 out of the 14 box.
Right. So 9 and 9, 5, 5, 9, 9, 9, 9, 9. And this is even, and those are even, so this has to be a 9, 8, 4, 2, not a 4, 4, 9, not 9, 9's out of there, none of those are 4, 5, 6, and 9, not a 9, not a 1. Eight is out of there.
Box
6,
7,
8,
yeah.
6, and it could be a 2. 6 and 9. That's 2, 3. That's not 2. 6, 9 takes 6 out of all of those, which could have been done by that. 4, because that can't be a 6. Or not a 4, because that can't be a 6. 3, 4 pair makes that a 2. An 8, not a 2. Not 8. 4 7s. 4. Oops. This is a 4. That's a 6. 6, 8, 4, 8. Not 6, not 6, not 4, 4, 8. Makes that a 6, not 8. 7, 9 pair. 6, 9, 8, 6, 3. Means this is 6. This has to be 3, as these are both 2s. I'm just going to take the colors out of all of that. 9, 7. So 7 and 4 is out. That makes that a 3, 8 pair. 4, 4, 2, 3, 8, 3, 4, 7, 5, 9, 8, 9, 7, 8, 4, 7, 4.
That one was hard.
Yeah, I agree. The 7 in here, I'm not even sure how I saw that.
Yeah.
But even then, it didn't get us very far. The thing that didn't really get the puzzle rolling was until we found this one, and the fact that this couldn't be a 2-4 pair. And I guess the thing that I find a bit annoying about that is I had to start filling the grid in with digits in order to see that. But I guess that's not necessarily. I mean, that's part of how to solve Sudokus. Like if you get stuck, then I mean, you might as well just start pencil marking everything. It's just after watching a lot of the Cracking the Cryptic videos, it's just sort of seems like both Mark and Simon kind of lean away from that. Even though Mark kind of has the nickname of Pencil Mark, but still.
Right.
Yeah. All right. Yeah, any other comments on this puzzle? It was still a good puzzle, even though it was hard. It was just hard. Alright, next puzzle is Sneaky Killers by Skojo. Normal Sudoku rules apply. Digits may not repeat within a cage. Digits in each cage sum to an unknown total. A white dot between two cages indicates that the totals in those two cages have a difference of x. The value of x is the same for every white dot, but must be deduced. Okay. Digits may not repeat within a cage. Well, that means this is automatically 45. And I guess maybe what I should do is mark those in red, because these 3 digits are those 3 digits are those 3 digits.
Yeah. Well, you can stripe the whole top row.
That's true. These, if those are blue, then those are blue, and those are blue, and then we get yellow in these. Yellow-blue is the same here, and these two cages differ by some amount that determines how all of the cages differ.
It's red.
Oh yeah, that's true. Everything differs by the sum of red.
Well, that's interesting, because box 1 to box 4.
Yeah. I mean, we've got between 3 and 30.
Yeah.
Although, we've got some 1s to 17s, so the biggest difference is 16.
Ah, but there's a 1-to-1.
Oh, there is a 1-to-1. So, the biggest difference... Well, the smallest difference is 6. The biggest difference is 8.
And there's also a 1-to-5.
Where's the 1 to 5?
Going from between box 8 and box 9, top row.
Oh, right here.
Yeah, although that 1 falls below it, but 10, that's a minimum 11.
Well, 5 digits is minimum 15.
Well, but they don't... Oh, that's right, because they are all in the same cage, so they can't. So
Can't repeat.
15. Right. So that one is going to be minimum 6, right? For the single?
15 minus 8 is 7.
Okay.
and then maximum 3. And then 9 plus 8 is 17.
The red has to sum to 7, 8, or 9?
No, 6, 7, 8.
6, okay.
Which means this cannot be 1, 2. Because 3 plus 6 is less than 10.
Well, red can't be 9. But 6, 7, or 8. Yeah, I think you said that.
Yeah. Because if it was 9, these two wouldn't work.
Right.
And it's minimum 6, because red is 3 digits wide. Six digits is 21. Although 3 can be 24, it would have to be smaller than 21. Because 21 minus 6 is 15. So this is max 15. Well, I guess not max 15, because this is only minimum 21. But 21 minus 8 means this is minimum 13.
Right. But the 3-cell cage in box 4 sums to the same as that 5-cell cage between boxes 5 and 6. No, not necessarily. No, never mind. It's not.
Yeah, this is 21, or this is a 6 cell. It could be, or it could be plus and minus. Although it's more likely to be plus and minus this way, if it is that way. This is minimum 6.
No.
7.
Since red sums to 6, 7, or 8.
Yeah.
The single would be minimum 1 plus 6 would be minimum 7.
Right. Which means that this must be smaller than this. Because it's not possible for this to be greater than that.
Right.
So this one is maximum 17. Plus 8 would be 25. So
And
this
you
is
can't
max
do that.
16 now. To get to 24, and 24 plus 8 is 32, which I don't think there's a reason you can't do, because 45 minus 6 is 39, so that's your maximum in 6.
All right, if we look at the cages between from box 2 to box 3, we have, if we take out the blue, because that's the same, that means it means all of yellow but the difference between those two boxes is red. And it's got one yellow. So,
let's say this box was bigger than this one. Because let's say this is, I don't know, 30, just to put a number on it. If we subtract red, let's say red was 10, then this would be 20. Well, I don't know. I don't know if that number is making sense, but
well, because those 3 yellow plus red, or it could be minus red.
If one of these two,
I'm not mathing well. I'm not mathing at all.
we know the difference between them is red. So let's say this was yellow plus red, and this is just, or no. We know that this is equal to this, and there's an extra group of red somewhere. Either on this side or on this side. Because if this was 30 and the difference was 10, then this would be 20 or 40.
Not seeing it. I should be able to see the way that's going.
Yeah. So we've got, here, okay. So Sudoku notepad time. We've got yellow is equal to red plus 1y. And now this is plus or minus red. Is that correct? Because this
Right, yeah.
plus red is equal to yellow. Okay, so our two options are plus red, and then the same equation minus red. Now, if I have red on both sides, I can subtract them, and now that's saying that yellow is equal to 1 yellow, which is clearly false. So, this side has the extra red. If I add red over here, then I get 2 times red plus 1 yellow is equal to yellow.
Right. So the sum of red would be equal to the sum of the 2 yellow that are on the outside.
Is that true?
Yes. Yes. Because if yellow, which is all 3, which would be
Uh-huh.
y1, y2, y3 is equal to 2 red plus y, what at question mark, or yx. Yeah, we can just call that 1, 2, and 3.
Right, and then if we subtract... Okay, yeah, that makes more sense. So y2
Red.
and 3 is equal to twice red.
Right. Math is hard right now.
And we know that red is equal to 6, 7, or 8.
Now, if red is 6, that's 1, 2, 3.
Yeah.
And y1 or y2 plus y3 is equal to red, which would be 6. Well, 6 and 2 is 1, 5 or 2, 4, and you cannot do that with the 1, 2, 3. So red cannot be 6.
Wait.
I'm confused. If red is equal to 6,
Yeah.
then the 3 that make up 6 are 1, 2, and 3, right?
Uh-huh.
And since y2 plus y3 is equal to red, which in this case is 6, well, the two ways of making 6 in 2 is either 1, 5 or 2, 4, and you cannot do that with the 1, 2, and 3.
Yeah, but it's twice red. Right? Because we said that these two boxes, because we've got blue in here, we've got yellow plus blue is equal to red plus blue plus y1. And since we know we have the blue on both sides, we can just remove it. But then the dot means that one side is plus or minus red. right? Because we know
Right.
that these have to be the same, these two groups, because this is the overlap. And so the difference between these two is red. And now, so this side is plus or minus red. But if it was plus red, then that would mean that yellow is equal to yellow 1, the first digit in yellow, which is clearly false. So it has to be yellow minus red. And when we take the subtracted red over here, now that ends up with 2 reds over here. But we know that yellow is y1 plus 2 and 3. Subtract out y1 from both sides, so that gives us 2 and 3 is equal to twice red, which is 12, 14, or 16. And you can do 4, 8, or 5, 7 to get 12.
Oh, right. I told you I'm not mathing well.
Yeah. Although that does mean that box 3 is the cage in box 3 is 45 minus 12, 14, or 16, which is going to be 33, 31, or 29. Because we know, so then knowing that, and knowing that box 2 cage is equal to yellow plus blue, and box 3 cage, and then cage is equal to red plus blue plus y1 and the box 3 cage plus or minus, minus red is equal to the box 2 cage, which means that we should be able to figure out the box 2 cage. If it was 33, we would be subtracting a 6. No, it was this minus red that gave us this. Or it was this plus an extra red that gave us that. So it was plus red over here. So that would be 39, 39, or 39, wouldn't it? No. That would be 37 and 38. Because red is 6, red is 7, or red is 8.
Right.
Which I guess we could have started with that instead of this stuff over here.
But that's what we saw first.
Yeah. Because there's no way to go plus red from the box 2 cage, because that would end up being 45, which clearly this is not.
Right.
So I guess maybe we go then to box 4 cage. Which could then be 39 or 27. 38 or 26.
Well, box... No.
I definitely messed up. 31.
No, that's not box 4 cage.
Oh, right. Yeah, that'd be the box 5, 6 cage.
Yeah. And it's going to have to be minus red.
Does it have to be? I don't think there's any particular reason why this couldn't be red here.
Yeah. Okay. Because box 3 cage was box 2 cage minus red.
Although I guess if the box 4 cage is maximum 30, you couldn't do 20 or 39 minus 6. You couldn't do 38 minus 7, but you could do 37 minus 8. However, this is maximum 7, which means that this 7 plus 8 this is maximum 16. If it's maximum 16. Say again?
7 plus 8 is 15.
Right. If the box 4 cage is maximum 15, then I can't subtract 6 from 27, so then that removes its ability to be 6. I can't subtract 7 from 24, because that would be 17. So then 21 minus 8. 21 minus 8 is
13.
And 13 minus 8, this is the box 1 cage, is 5.
Yay, we got something!
Yeah.
Well, we know red is composed of 1, 3, and 4.
You're right. Because those are all the same. everywhere.
Okay, and 8 doubled is 16. So
Right.
y2 plus y3 is 16, so that's a 7-9 pair.
That's true.
And box, so
This is 24, isn't it? These three, if this is 21?
Yeah. 21 and 24 is 45.
And our box 4 cage is 13.
So that would be 7. And then 1, 2, 3.
So this is 15. And 15 minus 8 is 7. I think. I hope.
Yes, 15 minus 8 is 7.
Oh, and it's 8, so this is 1 and 9. And this has to be bigger than 9 plus 8, so this is 17.
Well, the bottom has to be... No, it doesn't have to be 1. Because it doesn't have to... It can't be... It can't be 1, 2, 3, 4, 7, because 1 and 7 would both have to occupy that bottom spot.
Right. So this is
So
1,
1,
because
2,
we have
3,
to have
5,
a 1.
6.
And
it
4
can't
is
have...
out.
Yeah. 1, 2, 3, 5, 6.
So
Which
4
leaves
and 8. And this is no longer 10, because we can't put a 1 in
12.
it.
It's 12 or 16.
It can't be 12, because 12 would require... Because without a 1, it's minimum 14.
Well, the 8 plus 8 is 16. Yeah, that has... that because I was going to say it can't be 7, 9 for the 16 in the box.
Right. So 4 plus 8 is 12.
12.
Which is going to be never 6, and it can't be
It's
4,
gonna be
8,
3,
or
9.
5, 7, 9, and... Oops. That's 9, that's 3. 8, 9, 1, 4, 2. 1, 3, not a 4, so that's a 4. And this is 15. So this has to be 15 minus 8 is 7. But it, that could be 1 and 2, and that could be 4.
Right. And 15 plus 8 is 23, which is 6, 8, 9.
1, 2, 4, or 6, 8, 9. And 7 plus 8 is 15, but this is minimum 21. So this has to be 23.
Okay, and the 6 has to go on the top because of the 5, 6 pair.
And this is minimum 21, so it has to be 23 plus 8, which is 31.
Yes.
This is 21. This one is 16. This cannot be 8, because none of it can be 1. So 16 plus 8, again, is 24. And places a 9 there. Left over in this column. 2, 5, and 6. Well, 2 and 8. Go ahead.
In box 9, what's left is 2, 3, 4, 5, 6. Okay, if
This
2
is
plus 8,
maximum 11.
if that's 2, then that's 4, 6. If that's 3, it's 5, 6. It can't be 4 because that would be 12, and 7, 8, and 9 are all used up. So the square can't be 4 or 5 or 6. So it's either 4, 6 or 5, 6. So those can't be 2.
So this is our 3.
But 6 has to go in there. Oh, okay.
I think.
Well, I was...
No, I guess that is...
Yeah.
Never mind. 6 is out there.
2, 3, 4, 5, 6, yeah.
7, 9. 7, 9. 2, 5, and 6.
What about 8? Oh, no, because 8 goes over...
It's here.
Blue.
5 and 6. Two and 3. That's 3.
That's 5. Yeah.
Yeah, I think I messed that one up completely. Because we have to have a 3 in this 16.
Right.
Now we also have to have 2.
Yeah.
And the 2 can't be in here because that's 2, 5, 6. So that's 2. And now it can't be 5 and 6, so it must be 4 and 7, which is going to fix these. And this. And what's left over? An 8?
8.
Which is going to place our 8 in blue here.
Oh. In box 7, the 5, 6 is going to add... Yeah. No, it's not going to be 5, 6. It's going to be add to 5 or 6. Because it's plus 8 and there's an 8 over there.
So this is 5, 6.
5. Yeah. And there's column 4 has a 2, 5 pair.
7, 4, 7, not 7. 4, so this must be 1 or 3. 1, 4,
2, 5.
2, 5. 1 or 2. Eight, 6, 1, 9, 2, 3, 7, 4, 5. I hope I did that right. 2, 3, 4, 5, 7. I think that's correct.
Yeah, well, we know across row 4 is 1 through 6.
4, 5, 7, 8, 9. 6, 9, 8. None of those are 7, not a 2, not a 3, not 1 or 3. And this, we know what its sum is. It's 31. And it can't have 6 in it. Is there another number it can't have in it?
It has to have both 8 and 9.
Does it?
It looks like
Okay.
it.
Where's 9 in this row? It can't be in these two, and then the 9 here and here force it here. So it does have 9 in it. Oh, and I guess looking at these, now you have to have...
Yeah, looking at those two, it has to have 8 and 9. And 8
so 8's
is going to
here
have to
then.
be beside the... Yeah.
2, 5, and 7. That's 2, 5, 7. 6 then. 4, 4, 3.
What happened to the... Something's wrong.
I guess I could click this button and it's our only options.
No.
So there's no 5.
5 comes out.
3, 4, 5, 4, 1, 2, 3, 5, 1, 5, and 2. And that is done. I like this puzzle. Alright.
I did like that puzzle. It was hard, but I liked it.
Yeah.
It probably would have been a little easier if we'd been mathing better, but...
Yeah. Although, if we'd started with actual values, it would have helped, rather than trying to do it abstractly. Because if we'd done actual values, we'd have known, okay, we know this is 45, so this ends up being 39, 37, or no, not 30, 39, 38, or 36. No, 37. And then, from there, what does this have to be? Well, it can't be plus that 8 again, because then it would, or whatever value, because then it would be back to 45, which is clearly wrong. So it had to be subtract, and then that gets to here, and then that gets to here, which comes back to here, and this has to be incredibly small. Yeah, that was... but once we started doing that logic, it was very obvious with the numbers. But yeah, I think it being late made it pretty difficult to start. But yeah, still, even being tired and all that, we got it done. So, let's see. We've got 14 minutes. Do we want to start another one? We probably won't be able to finish it.
Sure, we can go ahead and start one.
Okay.
I don't mind.
So, this one is King's Gambit by Gemma Owain. Maybe? Hopefully I pronounced that correctly. Normal Sudoku rules apply. Digits along an arrow sum to the digit in the arrow's circle. Digits cannot repeat in a gray region. Cells that are a king's move apart in chess may not contain the same digit.
Well, the gray regions are each 1 through 9.
Right. Well, these all have 3 cells for their arrows, so 6, 7, 8, 9. And this cannot repeat in a king's move. So this digit in gray has to be one of those two. Now, this could be a 6, in which case that's a 6, but this can't be a 6 because this is on this arrow. So this is not a 6, so these two end up being the same. And this isn't a 9. I guess I will go ahead and mark these in green. Oh, this one also has 3 cells on it, 6, 7, 8, 9, but it's on an arrow, so it can't be a 9. And this is 7, 8, 9, because it's got at least a 6 on here, plus 1 is 7.
Well, and where does that one go on its gray shape? Because all but those bottom two. Yeah, it wasn't as helpful since it didn't have the little squiggly.
Yeah.
Well, then doesn't it make that going from box 8 to box 6 blue arrow make the middle of that 1, 2, or 3?
Right. These are minimum 15, plus 1 is minimum 16. So this cannot be a 6, because if this was a 6, and this was a 9, you've already got 15 covered there. So you can't have 6 there. Now, these can't both be 7, but they could both be 8. Where is yellow in this box? It's not here, it's not there, and it can't be there. That's not that helpful. It's still a lot of locations it could be.
Well, where's green in box 1?
We know it's not here or here, and it can't be there, and it can't be on its arrow again. So that means green is down here. How about in box 5? It's not here or here, and it can't be on its own arrow.
Well, it can't be on the red arrow either. Because it's minimum 7. Green is minimum 7. And yellow is max 8.
Right.
It can't be on green. Can't be on the gray in box green.
Right. So this ends up being not green.
In box green. Yeah.
Yeah. Tired brains make for some interesting communication, but we got where I think we're at on the same page at the moment. So now, could this be 7, 8, or 9? If it was a 7, you've got 1 and 2. So no. So this is 7, 8, 9. And that means green has to be in here, but green's already in this gray U shape, which takes it out of there. And now, where is... well, actually, it has to be one of these two. And that takes it from there. Excuse me. So yellow in this box, but we know it's not here or there. Can't be on its own arrow. Like that. I don't know if yellow's as useful.
It doesn't look like it.
Where is yellow in this column? It's not there. It's none of those, and it's not in the same box. So it's either here, or it's on this arrow. Okay. I guess where is this digit in this column? It's not in the same box, it's not in gray, and it can't be green. Whatever this digit is, it has to be one of the three digits that's on there. This digit isn't as useful as it could be that one.
It could be what one? What?
This one here could be there.
Uh-huh. Right, yeah. Okay.
I don't know if this is useful, though. Yellow in this row has to be one of these four. And in this row, it couldn't be this one. We would actually see all three possibilities in row 5. Alright, well we know that this digit is not green or yellow. So let's call it blue. Where's blue in this U shape? Well, it's not in this box. It's not green.
Well, Are we looking for blue?
Yeah.
Okay, it can't be on the arrow for 789 in box the 789 in box 4. Blue can't be on its arrow. Because if it's on its arrow, at least in the first spot, it would have to be the 6. And green
Yeah.
would have to be 9, but then that would be 1 2 on. Oh no, because they could both be, the 1 could overlap for the red. Never mind. Because
Yeah.
I was gonna say that would prevent a 1 from being on the red arrow, but no, they share a box. Ugh. Yeah, apparently I'm not.
It is 10. Do we want to hit the stop button for this puzzle?
Yeah, probably should. Because obviously my brain's not working so well tonight.
Yeah. Alright. So, guess we can stop recording. So we'll come back to that puzzle next time. So let me go ahead and save all of those into the video description. Edit that right there and save. And then, yeah. Alright, so any final thoughts before we sign off?
I barely had any first thoughts.
Yeah. Yeah. So tomorrow I won't be available for Sudoku. So next
Okay.
time will be on Monday again,
Okay.
unless something else occurs. But other than that, anyone who has watched this far, thank you very much. Make sure to like, comment, and subscribe to all of those YouTube engagement things. But yeah, and then we will see you in the next video. Goodbye for now.